Hi everyone, this is Yaqian Chen from Chinese University of Hong Kong, Shenzhen. In this summer research program, we studied the Interestingness prediction system under the guidance of Professor Sebastian Xie. Interesting prediction system is currently underexplored, but is crucial for many practical applications, such as autonomous exploration and decision making. For example, for autonomous exploration robots of the subterranean environments, we find it interesting to have a hole in the wall and change its future trajectory planning. However, some users may not quite interested in the holes and pay more attention to things with construction workers. For another example, in urban area, most of the autonomous driving system is also required to detect certain things based on users' preference, a closed vehicle, a huge street sign. In general, our model is able to classify images given by robots into two classes, namely interesting and uninteresting classes, based on only a few labeled training datasets given by users. Main difficulties of our project lay on four aspects. First, the number of training datasets is limited. Exploration robots often required to detect interesting things online. For an unknown environment, users are only able to give a few training datasets to tell their preference. Second, detection objects are not determined. Previous detection systems, like autonomous driving detection systems, are very mature and often accomplish the accuracy near to 100%. However, they can only detect certain objects given by system builders in advance, like cars and pedestrians. Detection systems are not be able to be robust enough to tell interestingness under any given environment either. In the project, we expect our system to be robust enough and will work under any given environment. Last but not least, images belonging to interesting classes are very different from each other, and sometimes will confuse the classifier. To this end, instead of detecting objects that users may be interested in, we choose to classify the robot's input to images by comparing the distance between each training dataset to see if they are closer to the training images belonging to interesting class or uninteresting class. Our model mainly has three modules. First, we use the k-means algorithm to cluster the images into 64 groups to initialize the image data for the later training process. Then put the initialized position into the training model based on VLAD network. Last, put the testing dataset and get the predicted classes. Simply use the voting algorithm. For clustering process, we build a convolutional neural network using VGG16 architecture neural network as the baseline encoding framework to encode the input raw data. Then use the k-mean cluster algorithm to group image data. The output of clustering process is regarded as the initial training data, the encoded image data, and the class centroids given by the clustering will be the initial parameter for the model in the next training process. In training process, each image will be dragged from the training dataset as the query dataset, then randomly choose one image from the class, which is the same to the class of the query dataset, then choose three images from other class as the support dataset. Encode both query and the support images through VLAD network. The VLAD network used in the training process consists of two parts. The CNN encoder with VGG16 as the baseline framework and an extra VLAD layer as the main component of the VLAD network. VLAD layer is inspired by the vector of the locally aggregated descriptor image representation commonly used in the image retrieval and image classification. We also choose to use triplet loss function, which separate the pictures belonging to different classes and move closer pictures belonging to the same class. In testing process, we first use the similar network to encode input test image and training dataset through comparing the Euclidean distance between the encoded dataset of the given training data and the input testing data. We will find the image which is closest to the input test image. A simple voting algorithm will be used during the classification. The system will output the top 5 candidates which are closest to the testing image, comparing the proportion of the negative data in the candidates with the threshold. As a result, our model on average increased the prediction accuracy by 30% compared to the state-of-art classification models like CNN, prototypical network, and matching network. Thank you very much for listening.